then 6 is over to the left, right?
Mhm.
Alright. 6 is, oh good, I love ones. 1 squared. My favorite is 0, because everyone, what's 0 squared? 0 plus 2, zeros are great. Like here we go, 1 squared, sorry, that's 1. Oh good,
Oh, that's
easy math, let's see.
6.
See, 6. It wasn't like the last one that I made up with the fractions, good. See, it's 6. Now, final answer?
No,
I
5.
got it easier when I can just go back here, erase plus C and put plus 6.
Yep. Mhm.
I should use this one. This one looks best. There you go, you got it. Alright, let's do some trig.
What
Don't
about,
worry, Owen, you're gonna get much, do you know how much more practice you're gonna get on this? Section 5.2, section 5.3, section 5.4, over and over and over, you will be doing this. So you're gonna get a lot, I didn't want you to think like this is one section, we move on. You just build on this. That's all we're doing in chapter 5. We're finding antiderivatives. But we see all the application, and what it means. What's it mean to go from velocity back to position? Right? What's it represent graphically? We put in numbers. What do the numbers mean? We'll talk about that. Cool. And work on that one?
Yeah.
That would be the final answer, right? I was able to put the C in. If they didn't give me this, I just would have written plus C, right?
Yeah.
Professor, what about number 41? Did they do like double derivative, number 41?
Let me look at that one. Oh yeah, let's do it. And when they give you second derivative, you can go all the way back to the original. Now when I keep writing backwards, I promise you I won't do this all the time. When you're writing this in your notes, feel free to flow like you do write always, top to bottom in the notebook. But I'll do it, this is probably one of the last times I'll do this to go, hey, you're going this way, so I gotta go really low here now. F double prime,
Theta.
did they use theta?
Yes, sir.
Alright, what do they got now?
Sine theta plus cosine theta. And f of 0 equals to 3.
Up. So here we go. It's an IDP again. They gave you a couple numbers. What did they give us?
F of 0 equals to 3.
Okay.
And f prime of 0 equals to 4.
Alright. 2 initial values, huh? Alright, can you get to F prime?
Yeah. So negative cosine theta.
Oh, I love it. Look, you're going this way.
Minus sine theta.
No,
Minus, we're going from a positive sign to a negative what?
cosine
Negative cos, so you're negative cosine.
plus sine theta.
Negative sine theta.
And a positive cos goes to
Positive sign.
do great. And when we're going this way, aren't we? For antiderivative. Does that make sense? Before we differentiated, no, we're just going that way. Negatives on the third and the fourth.
And then include.
So you're saying plus sign, huh?
Plus c.
You're like, should we go that? Well, let's stop. Let's stop for a second and figure out C, huh?
Anything else?
And watch. What did I tell you? They love to use 0. So you'll be using these a lot, right there.
Mhm.
So help me out. Ready? 3.
No, it's 4.
Oh, thank you. I was reading the wrong one. When this has a prime on it, look. That's a 4. Negative.
Cosine 0.
Everyone help me out with this. Cosine of 0.
1.
Good. Now, Amber, sine of 0. You just look. See it?
Oh, okay, so sine of 0.
Do you see it right there?
Mm-hmm.
The sheen of Charlie Sheen?
Mm-hmm.
0.
0.
I know, if you didn't know them yet, probably after the next few sections, you'll know sine of 0 and cosine 0. Because they come up so often. Plus C. Everyone add a 1 on both sides? Let's see.
5.
Well, I'm going to write it again. Let me write it again, everyone. F prime of theta is negative cos theta plus sine of theta plus
5.
5. But now we gotta get all the way to what?
F.
F.
F of theta. So that becomes negative cosine theta minus sine theta.
Hey, did I mess up? You're like, yeah, what's the antiderivative of negative cos?
Negative
Kayla, I'm just going over here, right?
Negative
Negative
six.
sine. When I teach Calc 3, I still see this written on tests. People just use it as a guide. Even though you can do it in your head, just like a little safe zone. What's a positive sign become?
Negative.
Is this 0?
No, 5 theta.
Good. Does everyone agree?
Why is it 5?
Do you agree? Think about it. The derivative of 5x was always 5. So what's the antiderivative of 5? 5x. Well, it has theta, so we'll use 5 theta. We're doing that power rule thing, right? When you do this, well, it was a 0. It was 5x to the 0, so it becomes 5x to the 1 over 1. I think the easiest way to see it, though, Amber, is remember this derivative was that? So now you're going that way.
Yeah.
The weird thing is a lot of times people accidentally put 0. We're so used to derivatives being 0 of constants, but the antiderivative constant becomes that constant with an x. Well, in this case it was a theta, alright? Because it was all in terms of theta. Now I still have to put a plus what?
C.
And when I already used C in this problem, give me another letter.
C1
A.
or K.
K, D, yeah, I love it, you know? Whatever you want, true? You could still use C, but since I already called that C, I might as well make up another constant. Just use like D or something.
Do you
I'll
have
call
to
you
add,
D.
Do you have to add a constant?
Yes.
Oh, you have to.
Mm-hmm.
Yep, because you did an antiderivative, you have to.
Wouldn't the 5 be the Oh, because then you're going to the.
You got it. You got it. Now, do we have enough information to get D?
Yep.
Uh-huh. F the 0 is, alright, you're 3. Here we go again. What's the negative sign of 0?
0.
Cosine of 0?
1.
5 times 0 is?
0.
If you're wondering, these are where the errors are made.
4.
It's not in the calculus. It's usually in the 0, 1 thing. Student just gets, like a -1 because they thought the cosine of 0 was 0. Cosine of 0 is 1. What do you get for D?
4.
4. So final answer, what is it? Keep you on your test, right? F of theta
Minus cosine theta.
minus theta minus cosine theta plus 5 theta plus
Plus C.
and then I have to put anything else, right?
Never put C.
No, why? We already took care of when we found them. Because it's initial value, does that make sense?
Okay, gotcha.
Yeah, he's got it. So on an initial value problem, you're gonna find your C or your D or your E or you will find those. Unless they only give us that, then you would have to put it. If they, as long as they give us enough initial values, plural. Good deal. Hey, same stuff. The author likes to use S for position, okay?
Mhm.
What letter does he like to use for velocity?
B.
B.
B. And what letter does he like to use for acceleration?
A.
So keep in mind, we already know this. Position, velocity, acceleration. Velocity is rate of change of position with respect to time. Acceleration is the rate of change of velocity with respect to time. This is just like this problem, but are you doing copy? What if this was the problem? What if this was A of theta? Then I could have written this as what? B of theta. This would have been what?
S.
B of theta, and then this finally would have became the.
S.
So I just want to point that out, and we'll do a problem like that. I'll pick one from here. Does that make sense? So if you see that, on the test, if I'm like A of t equals this, find S of t, you know, like, oh, A of t is acceleration. I have to go through velocity to get the position. That sound good? Alright, try this guy. Can I raise? Good. Hammer, sometimes they don't even write IDP, they don't even say initial value problem, but they will just give you numbers.
Okay.
Okay, they'll just write something down like that. So, alright, here. B 0 equals 5.
Which number is this one?
This one, I'm doing one like number 61,
Like 61, okay.
okay? So when this one's like 61, but I put 61 for practice, so I didn't want to do exact 61, so it's kind of like we did with that. Remember the one with the straight line? Let's just change it up a little bit. This is like 61, anybody want to know the page? Page 349. So it's like 61 now, B of 0 is 5. S of 0 is 4. And here's what you got. Now, maybe from now on, since it would be like this on a test, we can write this way. Right? Oh, we got it. We got it, Professor Messer. You go this way, right? All right, we got it. So now, A of t equals, they wrote 2t plus 1. How about t minus 3?
Okay.
Let's try that. Can you, the directions, let me read it to you. A particle is moving with the given data. Find the position of the particle. So you gotta find the position. Now what I would write is this. Just to give you a heads up, like, you gotta fill in this blank. S of t means what? Position. But you gotta go from acceleration through what?
Velocity
Velocity. Then go from velocity,
to position.
and you gotta get these initial values in those constants, right? Alright. Don't do derivative, do antiderivative.
Anti.
T squared.
Is that it?
Over 2.
Over 2, right? I know, we'll always do, you pump it up, then you divide by it, right?
Mhm.
You pump it up by 1, divide by that. Pump it up by what? Divide by.
Plus C.
Minus 3t.
Now what is a 3? Here we go again. Here comes the constant. 3, what letter?
Minus 3T.
Then minus 3t. And then you said plus c. I love it.
Plus C, yeah.
I gotta make sure my t doesn't look like a plus. Here, I'll swing it. Now, do we have information against c? Ah, they gave us something. I need this one. So the 5 goes here. But I love zeros. What's 0 squared?
0.
3 times 0.
How come you don't want me?
C plus 5.
C is 5. Now let's write it again.
Could you explain where you got the 0 from?
Oh, you bet. Now they gave us this, right? Like Farad, they gave me this information here. I love zeros. Well, cosine of 0, you gotta be careful because it's a 1. Sine of 0 is 0, but what's 0 squared? 0. What's 3 times 0? 0, right? I'm substituting the zeros. This is where I put the 0 in for t, and then this is the v of t. So the v of t is that 5, and then the 0 is going in for all those little t's, right? Does that make sense? You gotta love zeros. I'm glad you didn't say like, you know what I mean, 2/3 or something. Because then you're like, oh gosh, 2/3 squared? I know. By the way, a lot of initial values are at time equals 0, if t is time. So, I rewrite this. I put my constant back, which was what number?
5.
Now we gotta get s of t. We'll give it a shot, and I'll catch up to you. Because I don't think we've done t squared over 2 yet. Just still do it. That 1 over 2 just stays in front.
So we just did the first part just to find the constant, and now when we have the constant, now we're trying to find B.
Now you're trying to get the s. You got b of t. You're at velocity, now you're trying to get the position.
Oh, okay.
So you're like halfway done the problem.
Yes.
Yeah, you're halfway done. Now, start pumping it up again. Antiderivative. Cubed.
Over 6.
And yeah, look, t cubed over 3, right, Saran? And but there's a 2 next to it.
So
2 times 3 is just a.
6.
Farad okay there? Yeah, there was a 2 sitting there, just sitting around. Constant stays, 3 times 2 is 6. 3t squared over 2 plus 0 or 5t?
5t.
I
Plus
love it. Be
6.
careful, it's gonna happen. You're gonna accidentally put a 0 by accident for derivative. Don't these constants always turn to 5t? Now what else do I need? A plus what?
Plus C.
C.
I already use c. You wanna use something else?
C.
D. In case
Can't
someone
you
watches
just
the
put-
video.
Can't you just put in 5 for C or D?
C, and that's why, C is 5, I didn't want you to get confused. We found C, which was that. Let's call this another constant, D. But now, how are we gonna find D?
You plug in.
Just.
Alright, help me out. Where's the 4 go? Where's the 4 go?
That's,
In brass.
So that's 4, right? And this is the S of T. Where's these zeros go?
For T.
Right, for out of every T, I'm putting 0. Every T, alright. 4 equals,
0.
I'll go off to the side here. 4 equals 0 cubed over 6 minus 3 times 0 squared over 2 plus 5 times 0 plus D. I like zeros. Just be careful, what's the cosine of 0? It's not 0, it's what?
1.
Be careful of trig functions, that's the only thing you gotta be careful of. And e to a 0, what's e to a 0? Those are the ones you gotta be careful of. You love zeros, because 0 times 0, 0, zeros, right? See them all pop up. Be careful of cosine 0 and e to the 0. D is 4, I think this problem is done. Let's fill in the blank. T cubed over 6 minus 3t squared over 2 plus 5t, and then what was D? There you go. Is that okay for the beginning, the test 4, stuff like that? I'll make sure to do one with sines and cosines like the last one too.